Congratulations! You are now the owner of a sophisticated new ICS Impulse system, developed in collaboration with Drs. Ian Kurthoys and Michael Hamagi and others at the University of Sydney. To assist you in getting the most out of your ICS Impulse system, we have included the training video. We hope you find it easy to use and that the use of the incorporated tips and information result in improved data collection and accuracy. A head impulse is a quick movement of the head which stimulates the semicircular canals. The patient fixates on a dot during the head movement. The ICS Impulse goggles measure the head and eye movement. The response is that both eyes turn to correct for or compensate for the head turn. This compensation keeps the patient looking at the target as the head is turned. The ICS Impulse should not be performed on patients with a neck injury or on patients who have been told by their physicians to limit or avoid neck movement activity. When you first start up your ICS system, you have three options when collecting data. You can use a temporary patient file and then enter the patient information later, or enter new patient information immediately, or you can open an existing patient file. Prior to placing the goggles on the patient, you need to make sure you prepare the goggles. If needed, you can clean the goggle housing. The goggle housing is made of molded plastic material which can be cleaned using a damp cloth moistened with a mild detergent and water solution. You want to ensure the goggles have a new, unused face cushion. To remove the face cushion, slightly flex the goggles out at the side opposite of the camera side and snap out the face cushion. Release the face cushion from the other side. Properly dispose of the used face cushion. Obtain a new face cushion. Align the tab of the face cushion with the hole on the camera side of the goggles. Ensure the face cushion is inside the nose piece. Slightly flex the goggles at the opposite side. Align the tab of the face cushion with the hole in the goggles. Double check both sides are fully inserted by pressing it at each side. The next thing you might want to do is clean the mirror. Use the provided cleaning cloth and gently wipe the mirror on both sides. The place where the patient is tested can vary, but must allow you to position the patient at least 1 meter from the wall, or other solid surface that can be used as a projection surface. Choose a wall that allows you to position the patient at least 1 meter in front of the wall. Apply one of the fixation dots supplied with the ICS Impulse system to the wall. When goggles are placed properly, they sit comfortably on the bridge of the patient's nose and will not slip during testing. Improper goggle placement may result in goggle slippage, and slippage will result in inaccurate data collection. First, you want to position the goggles on the patient's face over the bridge of the nose. Bring the strap above the patient's ears and around to the back of the head. Tighten the strap tight enough to ensure that the goggles will not shift horizontally during testing. Allowing some flexibility in the cables for head movement during testing is important. Clip the cable to the patient's clothing at the top of the shoulder. Ensure the eyes are wide open with eyelids positioned to not interfere with data collection. If required, adjust the skin around the eye. Tilt the bottom of the goggles out and away from the face, pulling the skin below the eye down and repositioning the goggle to hold the skin in place. Tilt the top of the goggles out and away from the face, pulling the skin above the eye up and repositioning the goggles to hold the skin. Pupil detection is performed to ensure that the system tracks the pupil properly prior to calibration. Position the pupil in the ROI, or the region of interest. Over here in the Calibration tab, you see the green square. You want to make sure the pupil is positioned within the green square. You can do this either by left-clicking and dragging the green square, or clicking on the pupil to center the pupil inside the green box. You can look at the pupil in one of two ways: grayscale image or pupil location. When it is in pupil location, the pupil is white and the background is black. In grayscale, the white cross mark signifies the pupil. Select Display Pupil Tracking. You will see in the real-time trace that the red is the head and the green is the eye. Select Auto Threshold. The system centers the crosshair on the pupil. Now the patient will stare at the fixation dot. Observe the green eye trace in the real-time trace window, ensuring that it is as flat as possible when the patient is fixating on the fixation dot. Click On to turn on both lasers. There are two laser dots projected on the wall. Ask the patient to look at the left dot, then the right dot. This ensures the camera is tracking the pupil. If the crosshair fails to track the pupil, jumps around or does not stay centered on the pupil, move the threshold slider to make further adjustments. Adjust the pupil detection by clicking plus or minus or by sliding the bar. In the calibration procedure, the patient is asked to switch their gaze between the two dots that appear when calibration is performed. As the patient's gaze switches, the system tracks the movement of the pupil. When the patient cannot be calibrated because they cannot see the dots, click Default to use the calibration default values. The calibration values are used to analyze eye movement during the lateral impulse testing. Click Run Calibration to start calibration. Ask the patient to hold their head still. Then ask the patient to look at the laser beam dot. Ask the patient to look at the left laser dot. Look right. Look at the left laser dot. The calibration values are automatically saved. The collection window displays and you are ready to begin testing. If you want to video record the eye during the head impulse testing, you have two options. Use the control buttons to manually start and stop the recording. To start the video recording at the same time as data collection starts, select the checkbox Auto Record, which will set the software to always simultaneously start the video recording when head impulse data collection. The Impulses settings defines how many valid left and right impulses are required before the test stops automatically. Here you see 20 left head impulses and 20 right head impulses. To change the number of suggested minimum head impulses for the current testing session, click the up and down arrows or type the number in directly. The maximum value is 999. 20 has been recommended by Drs. Hamagi and Kurthoys as the minimum number that should be collected for both left and right side. For patients with spontaneous nystagmus, select the checkbox Patient has spontaneous nystagmus. This prevents good impulses from being rejected inappropriately. The elapsed time displays along with the test date and test time at the bottom of the window. While performing the head impulse test, both the real-time trace window and the lateral impulse window display head and eye traces to assist you in understanding the quality of data being collected. There are algorithms built into the system that will reject bad head impulses. While you are doing the head impulse testing, you will want to look at the real-time trace window and the lateral impulse window. The real-time trace window allows you to monitor both head, displayed in red, and eye movement displayed in green, while performing one head impulse test. By monitoring the real-time trace, you can make sure the patient is cooperating and staring at the fixation dot. The lateral impulse window helps you perform good head impulses. The gray training lines represent the shape of good head impulses at a variety of velocities, 50, 100, 150, and 200. Positive velocities represent leftward head impulses. Negative velocities represent rightward head impulses. The actual head and eye trace are superimposed on top of the gray training lines. The eye trace is always represented in green. White dots display along the y-axis to indicate the velocity of impulses collected. Comparing the actual traces against the training lines helps ensure that the tester performs quality head impulses and that only good data is included in the analysis. The collection algorithm assures that only good head impulses are accepted for analysis. When performing the head impulse, you want to make sure it is randomized. Perform multiple velocities and randomized left and rightward movements. You want to make sure the patient cannot predict which direction and at what velocity the head impulse will be performed. Touching the goggles or the goggle strap while moving the patient's head can result in moving the camera, which produces artifacts in the collection data. Again, it is important the goggles are strapped on tight and do not move during testing. Standing behind the patient, place your hands on top of the patient's head well away from the goggles and the goggle strap. Ask the patient to stare at the fixation dot. Perform the head impulse by moving the head abruptly in a very quick motion like a kick. The tester should imagine a target point about 15 to 20 degrees to the right or left of the patient's head, straight ahead of them. The tester should try to turn the patient's head so that the patient's nose is pointing at the imaginary spot, moving it abruptly, trying not to overshoot the 15 or 20 degrees and trying not to have a return, just a quick direct head turn to the imagined target point. Hold it there for a few seconds and then slowly bring the head back to straight ahead or facing the wall. The key bit of feedback for the tester is that the movement should be precise. It should go up and come back to baseline with very little overshoot. If the head velocity looks like a sine wave, then you are doing it right. Look at your head impulses and compare them to the training curves. The head impulses should be presented in an unpredictable manner, in direction, and at varying velocities. After each head impulse is performed, you should look at the lateral impulse window and see if the head impulse you perform matches the training curves. Note how the head movement matches the gray training curve. Also note the white dot indicating the velocity at which it was performed, and whether the head impulse was accepted or rejected. The system automatically stops when the minimum numbers for left and right impulses have been reached. To manually stop the test, click Stop. Data collection will be saved. Or Cancel. Data collection will not be saved. The data is automatically analyzed and displayed in the 2D analysis window. Let's look at some of my first head impulse results. Here you can see the difference in results from practice. These 3 sessions took about 10 to 15 minutes, and by watching the training curves, there was instant improvement. Look at the head velocity in Trial 1, especially on the left side. They do not align well. Same in Trial 2, but in Trial 3, both the left and the right velocities align quite well. Now let's look at common mistakes. Here is an example of a head impulse that was performed too slowly. Notice that the tracing is broad and does not match the training curve. In this second example, the head impulse was performed at the correct speed, but the return was too quick. After performing the head impulse, you need to hold it there for a few seconds and then slowly bring the head back to the straight position. Regarding analysis of the data collected, the video will not cover understanding head impulse analysis. I refer you back to the user manual for this. We want to make one more comment regarding data collection. The analysis algorithm evaluates the good head impulses and ensures that the patient was performing the task appropriately. For example, if the tester performs a good head impulse, then the data is saved, but if the patient happened to blink or is looking around during the good head impulse, the analysis algorithm then discards the data as not being valid. Therefore, in the analysis section under the Test Info tab, you see the data that was collected as well as the data that was actually analyzed. You may find that some of the collected data was not analyzed. There are 2 algorithms to assure that good data is collected. Thank you for taking time to view the ICS Impulse training video. In 1 minute and 10 seconds, as illustrated in this video, you can assess the vestibular function of both ears. The entire test, including patient entry and reporting, takes less than 10 minutes. Please refer to headimpulse.com and the user manual for additional information.